And welcome back to our teardown video. This time it's a salamander shower pump, CTFORCE30PTS, which died, well didn't die, made a horrible noise. So let's see why. Well, this is just a quick recording of how the pump sounded about 8 months ago, or 6 months ago, and it's got louder and louder since. I wish I'd taken a recording before we finally took it off. At the end, I'm sure this pump could be heard several houses down the street. It was loud. So I had to dig deep in the pockets and buy a replacement. Hopefully the new one will last longer. Now let's just start getting the little bugger open and see what's in there making all that noise. Right, what do we have here? Mains coming in. Live, neutral, and the earth. We have water comes in here, round here, and up there for the hot or cold, and the same here comes in here, round there, and up there. There are valves that detect, or sensors that detect when the water is flowing, and there seems to be some sort of cross pipe and a big capacitor for the motor. Hopefully this motor is discharged. It's been off for a couple of days. I'll discharge that. The neutrals are all joined together. That's obviously live and neutral going down. Oh no, I don't know what that one is. Oh, it's a capacitor for the phase, isn't it? Because here's the other live. Let's get the sensor wires out of the way. Get that one out of the way. So that's live, neutral, and that, and one of the phases. Can we get the earth off? Yep. So that's the mains lead off. We'll have a look at that in a bit. Is there a whole stack of washers down here? Oh, another nut to hold this plastic body down. There we are. Well, that's not going to come off until these come off. So let's zoom back out. before I do that, on the off chance there's some water in here. That one. Well, some nice hardware, which isn't surprising, seeing as this pump was £300. Yeah. And no water's coming out of that one. These aren't exactly very tight. Ah, he says, unleashing another puddle. Maybe. Ah, that moved it a bit. Oh. Ah. What did that detect? Oh, it's very sharp. When this was running, you could hear it outside the house. It was so loud. Ooh, that is quite a nice machining. Let's have a look at the other end. Oops. More water. Oh, that one came off stuck to this. That's strange. This one's stuck fast. I reckon this rotor was coming loose and grinding, because this one, oh no, it's very sharp on the fingers. Oh, look at this one. Can you see it? Dry my fingers. Can you see the difference where it's polished? That's the housing from the other end. That's the housing from this end. So, and this one, you know, so this one just fell off. Bit of grinding, bit of strange colouring on there. This one seems hey. Chewed up the pump a bit, very chewed up. And this one looks like possibly starting to go. Oh. Possibly starting to rub there and over here. So this one was starting to go. Whether that was, I suppose, there's slight rubbing marks on there. Another O-ring. Yeah, look, this end. Look at that. Started to go. This is intermittent use. This is not like it's pumping full time. It's intermittent use. So I think if the next pump don't last more than a few years, it will be the last time I buy one of these because they're stupidly expensive. But the motor looks good quality on the inside. Maybe I'll take the motor apart. I've taken the pump apart, or the motor apart. This bearing spins freely. This one is a bit weird, but I can't seem to get it off the shaft. It's a bit wobbly. This one's pretty solid, but something here is a bit wobbly, whether it's the bearing or something. But as you can see, the rotor has been grinding away on the insides. Oh, it's heavy. Not sure if you can see in there. I can't work out. I can't remember which end it was now. This end, I think. Yeah, this end. Does it look like it's been grinding away on there compared to this end? This end looks, I don't know. Yeah, that looks worn, doesn't it? It's nice and shiny, whereas that end is a sort of uniform colour. So, that is heavy. Also, in this end was a seal, and this is what's left of it. So it all kind of stacks up that something big time let go in this one. Because here's the end from the other side, nicely intact. And I've got a messy bench to clear up. Bad wear on that rotor. And wear on that rotor. And the interesting thing would be is what's inside these, because they were literally there. So what the hell did they detect? This is the crossfeed pipe. And if you look into there, you'll see some sort of valve. And on there is the impression where that sensor sat. Now I did think it was detecting maybe the paddle going round, but the motor's too stiff for that. But there is something in there. And it moves up and down. But if you look here, not sure if you'll see it in there. If I get the light just right, can you see down there? You'll just make out possibly a circlip. Let's get the microscope in. Can you see the circlip embedded in there? Now, looking in there, I can't see how you get to the circlip, which is why I destroyed the other one. And the same there. But those bits in there, if you shake it, you'll see they're not out and they move. And then there was some sort of ball valve that could go up and down. A few bits with O-rings. And then there was this piece which is completely mangled, as I had to get it out, which has a metal ring, and then was a pin slid in the middle but got bent. But if you look there, there is a magnet. There was something rusty on the end of it, which is here. Can you see it in the microscope? Which is slightly magnetic, and or it is magnetic and a bit crunchy. So whether that's the end of it broken off, I don't know, because there seems to be difference in material. It's sort of goldy silvery with a black coating. But I'll dig it out. I'll carry on digging that out and we'll have a look. Well, there's the metal bit that was in the end, which is mildly magnetic, but you'll see from the scalpel blade it's got magnetized. What about the other end? It's quite a strong magnet. I got a feeling that the magnet moves up and I'm going to have to look at that circuit and see what the chips are. I've already found this one. If I can get the light to shine on it. 6P2684J, I think it is. And there's one in here. I might have to take the heatsink off to do that one. Anyway, moving swiftly on. Right, just to show the connections, this is the other lead. Buzzing out the circuit, it looked like we have a red is positive, the yellow is 0 volts, and the pink is the signal. So what I've done is here I have positive on the positive pin. I've got the negative going to the negative lead. The voltmeter is measuring the middle pin, the pink one, and here is my trusty decade resistance box in all its glory, and that's pulling the pink pin, the center, the middle pin up. On here I've got the magnet, and as we can see, as I bring it down, it switches. I can't hear anything in here to see where it's a reed relay, but if it was a reed relay you would only need 2 wires. Having 3 wires, I'm assuming a Hall effect device in here. And that's how it detects the water. As you turn a tap on, the valve or the float in the pipe moves up, and as it moves up, it obviously switches it on, and that then fires the pump. When the water pressure drops, it must then fall back, and the motor turns off. I don't really want to cut these open to look inside. There's no markings on them, but because they might be used for something else. Subscribe, it's free. Costs you nothing, helps my channel a lot, so hit that button. Hit that notification bell for future videos. Hey, and while you're at it, give this video a thumbs up, it all helps. Catch you on the next one.